Here's an example where we will actually be evaluating a differential for a given function. So we're going to find the differential, dy, for the function y equals x plus 1 over x minus 1. And we're going to evaluate it for the values x equals 2 and dx equals 0.05. So with that in mind, what we have for the total differential is that dy is going to be, in Leibniz notation, we would want dy over dx, the derivative, times the differential dx. Now that's going to involve us taking a derivative. So dy over dx for the given function, that'll be the derivative with respect to x of x plus 1 over x minus 1. Given that this is a quotient, we'll be applying the quotient rule. This will be low, d high, derivative at the top will be 1, less high, d low, derivative of the bottom will be 1, over the square of what's below. Now once we simplify this numerator, I see an x times 1 minus x times 1, those will cancel. We also have a negative 1 times 1 minus positive 1 times 1. That is 1 minus 1, and that'll be negative 2. So the expression for our differential is that dy is going to be equal to negative 2 over x minus 1 quantity squared times dx. This is the answer for the differential of the given function. Now, the given values that we have are x equals 2 and dx is equal to 0.05. So we'll point out that at x equals 2 and dx equals 0.05, this lets us know that dy is going to be equal to negative 2 divided by 2 minus 1 quantity squared times 0.05. This will be equal to negative 2 divided by 1 squared times 0.05. That calculation will be negative 0.01. Now to interpret what this actually means is that as x changes from x equals 2 to x equals, we're increasing by 0.05, so 2.05, y will decrease by about 0.1. Now, I'd like to put that to the test by actually evaluating the function at x equals 2 and at x equals 2.05, and we'll see what actually happens. So, to compare, we're going to find the actual change in y on the given function. So if we evaluate y at 2, this will be 2 plus 1 divided by 2 minus 1. That is 3 divided by 1, and therefore it will be equal to 3. Whereas if we did y equals 2.05, this is going to be equal to 2.05 plus 1 divided by 2.05 minus 1. Here's where I'm going to bring in a calculator to help us out with this. This is 3.05 divided by 1.05. 3.05 divided by 1.05. The prediction is that this should go down by about 0.1, so I'm expecting about 2.9 for this answer. We get 2.90476. Rounded at the 5th decimal place. So you'll notice that our answer is accurate at the 1st decimal place, but then there's some peripheral stuff right after that. So that is the computation and interpretation of a differential of a given function.